Okay, now we have the question. If we shave the small cubes to where they're only have dimension 0.9 centimeters, I say 0.9 centimeter dimension, being a little sloppy against my own advice with the words, but I want to keep this kind of intuitive right now. What I should say is we shave them down so each cube is now 0.9 centimeters on each edge. So we have a 0.9 by 0.9 by 0.9 centimeter cube. Okay, but I think everybody understands what this means. Then the question is, how many of these cubes would we need to fill the 10 centimeter cube? Okay, well, people did the calculation. Okay, you divide 10 centimeters, which is the width of our 10 centimeter cube, obviously, or the length or the height, whichever. And we divide that by the 0.9 centimeters, and we get 11.1 cubes of dimension 0.9 centimeters required to make a row. And then we're going to need the same number to make a layer and the same number of layers. So if we take this ratio and cube it, we should, we don't, but there's a caveat here, we should see that it takes this many cubes of dimension 0.9 centimeters to fill a 10 centimeter cube. Now if we actually calculate this and cube it, and I missed my estimate. I thought it'd be about 1334, but I wasn't thinking real hard. Probably wouldn't have made a difference. I'd probably done worse if I'd have thought a little harder. It's actually 1337. Okay, that would be 1337 small cubes. Now, that ignores the fact that if we have 0.9 centimeter cubes, we're only going to be able to get 11 in a row. But then we're going to have a little space left at the end of the row, aren't we? Okay? And we're only going to be able to get 11 rows in a layer, and again we'll have a little bit of a gap over here at the edge, and we're only going to be able to get 11 layers, and then we're going to have a little bit of a gap here at the top. And we're not actually going to be able to put 11.1 cubes in a row. Okay? Now, this is the ratio of the volumes of the big cube to the 0.9 centimeter cube, the 10 centimeter cube to the 0.9 centimeter cube, but we can't really get that many small cubes in. Really, we could only do 11 by 11 by 11, which is 1331. And we'd have some space left over, as I've described. And that space turns out to be about 6, equivalent to the volume of 6 cubes. 6 out of 1300 and some is about 0.5%. So we end up only filling about 99.5% of the 10 centimeter cube with cubes of this size. For now, we're going to just ignore that difference. Okay, so we'll say that it's going to be pretty close to the cube of this ratio, but we've got to be careful because if this number doesn't go evenly into 10 centimeters, we're going to have some space left over, and sometimes it'll be a lot more than the space that's left over in this example. Another observation I'll make is it makes a lot less difference if you were filling a 40 meter cube with 1 centimeter cubes. Okay, the difference between the number of small cubes you could actually fit in a 40 meter large cube would be a lot closer to the number that you could fit in if you first put them into 10 centimeter cubes. So I don't want to talk too much more about that. Just bringing up that there's a little bit of a discrepancy here, and we'll bring it up when it becomes important. It's actually quite an important idea that's related to a lot of other ideas we've seen in this course. So I wish we had a little more time so we could talk about this idea, but right now we don't. So I want to move on to a more symbolic representation of how we can talk about this sort of thing.